Welcome back, everybody. Today's video is going to start off with postulates, and this is going to be kind of an introduction into our geometric proofs. There are 7 postulates that we're going to go through that are in your book. They're on page 125 in the textbook, and I'm just going to go through and read each one. I would encourage you to write these down so you have them to refer back to. The numbers aren't necessarily important. It's more about the statement that I want you to know. You're going to be able to use these concepts in order to prove some things in our proofs, in our 2-column proofs, as well as to identify if certain things are always, sometimes, or never true. So let's go ahead and get started. The first one, 2.1, says that through any 2 points there is exactly one line. What that basically just is saying is that if I have the points A and point B, then I can only draw one line through those points. Okay, so pretty self-explanatory. 2.2 says through any 3 non-collinear points, that's important. Non-collinear means not on the same line. There is exactly one plane. So that's kind of just our definition of a plane. A plane is created by 3 non-collinear points, A, B, and C. So these 3 points would make a plane. The 2.3 postulate says a line contains at least 2 points. What that says here is similar to 2.1, except now we said we have a line and it says I have to have at least 2 points on it, maybe X and Y, but that I could also have more, for example, G or H. And technically a line has infinitely many points. So this just says if you have a line, it's going to have at least 2 or it could have more. 2.4 says that a plane contains at least 3 non-collinear points, so same concept. If we have a plane here, maybe I call it plane A, then I have to have at least 3 points, but I could have more. I could have an extra point here, I could have a line here, which remember lines have 2 points on them, so as long as they're non-collinear, you're going to have at least 3 of them or more. 2.5 says if 2 points lie in a plane, so let's draw that scenario. So here's a plane, and I've got 2 points. It says then the line through those points is also in the plane. So if I have 2 points on my plane, then if I draw a line through it, that also is going to be in the same plane. 2.6 says if 2 lines intersect, then their intersection is 1 point. We talked about that way back in Unit 1. So if I've got 2 lines here, where they cross is only 1 point, maybe point A. And then last but not least, if 2 planes intersect, then their intersection is a line. And that one's a little bit harder for me to draw, but remember we talked about how it's like 2 walls meeting or 2 pieces of paper that we're crossing. So here I've got 2 planes, the top and the side, and their intersection is this green line. Okay. So 2 lines meet at a point, 2 planes meet at a line. All right. So if you have any questions about the 7 postulates, let me know. The first 4 are very similar to each other. It's all about the wording and what exactly they're looking for, so be careful with those. But what we're going to do is practice identifying things from pictures using these 7 postulates. So let's go through some examples together. The first example says you want to determine if the statements are always, sometimes, or never true, and then justify or explain your reasoning. So in example 1 here it says a line contains exactly 1 point. Well, if you think back to our postulates, the ones where they talk about lines, we've got 2 options here. We've got that through 2 points there's exactly 1 line, or that a line contains at least 2 points. So in this case, postulate 2.3 would be the best resource for answering this. So a line contains at least 2 points. And so based on that information, if it says a line contains exactly 1 point, that would never be true because it has to have at least 2 in order to be on a line. The second one says any 2 lines M and G intersect. Now this one you have to be very careful because in our postulates it says 2 lines that intersect at a point. Okay, but so I could draw a line M and G crossing at a point. So here's line M, here's line G. But I could also have line M and G look like this. Here's line M, here's line G. So notice that this line M and this line G, they don't ever intersect. So in this case, this would be a sometimes. And your explanation could be that two lines can intersect to make a point, or they could be parallel and never cross. So there's a little bit of, you could add a little bit of explanation to it to justify whether it's always, sometimes, or never. In these two examples, we're going to be using the image at the right to identify the postulate that is being used. So you're going to be using 2.1 through 2.7. And here it says that exactly one plane contains the points F, B, and E. So let's look for where F, B, and E are. So if we look at those 3 points, we notice that they are non-collinear points. So I'm just going to write this down here as just a little side note. And what that means is that we can create one plane, which is exactly what this statement is saying. So if we go back to our postulates and we look at our 7 options, we know that 2.2 says that if you have 3 non-collinear points, there's exactly one plane. So in this case, we just you could write the whole postulate out, or you could put postulate 2.2. I will not give you the numbers on the test, so you'll want to be able to identify those written parts of the postulate that through 3 points, non-collinear points, make one plane. So that would be the explanation or the postulate you would use to prove this is true. Okay? And then in the second example, it says line BE lies in plane Q. So here's BE, not drawn, but we can draw it in. Okay? And it says that it lies in plane Q. Well, if you go back to your postulates here, we know B and E are in the plane. So back to our postulates, it says 2 points. If 2 points lie in the plane, then their line is also in the plane. So this goes back to 2.5. So we knew B and E were in the plane. So that means line BE also has to be in the plane. Okay. So 2.2 was for the first example. Postulate 2.5 was for the second. Like I said, having these handy in your notes will be useful when you're going through the practice problems, maybe even the mastery check. Just make sure you know the general rules for those postulates when you're preparing for your test. Okay? If you have any questions about the examples, let me know, but you should be good to go to the next video. Thanks for listening.